Okay, so we're going to try to talk about T cells. Okay? Okay, we're going to talk about MHC first. So what is MHC? It's a major histocompatibility complex. Okay? So let's talk about MHC Class 1 first. So first of all, what is MHC? MHC is the system of proteins. Proteins that are located on the surface of these cells. Good? Which cells? MHC Class 1 can be found on all nucleated cells. Okay? Good? And this is how it works. So imagine you have a cell, human cell, and this is MHC Class 1. Okay, it's fine. Now, do your cells produce proteins? 0 out of 10 question. Do they produce proteins? Yes, of course. So some fragments of those proteins get shipped to MHC Class 1 and they are exposed outside. Okay, so this is what's called endogenous antigen. Endogenous means that it comes from within. Are we clear? Now imagine that I am that cell and I stick this out. What does it tell my immune system? It tells my immune system that I'm fine. Okay? What does that mean, I'm fine? Well, imagine that I am getting infected with virus. Cells that are infected with virus, do they produce virus proteins? Gonna have to, otherwise how it's gonna replicate. So now your cell exposing on its surface a viral protein. What does your immune system see? I'm screwed up, right? Like I'm not fine. Got it? So that's kind of the point. Or this cell becomes malignant, cancerous, and proteins that are produced in the cell are altered, and they look like this. For your immune system that's used to this one, still, this is wrong. This is like, this cell has to, like, something's wrong here. Are we clear on this one, on this concept? Awesome. Now, what about MHC Class 2? MHC Class 2 molecules are on the surface of antigen-presenting cells. Which are dendritic cells, macrophages. This Simon MPhi is the common acronym for macrophages, and B cells. We good so far? So imagine that this is a dendritic cell. And this is your MHC Class 2. You following me so far? You good? Good? Okay. So in this case, dendritic cell, it's basically glorified macrophage. it takes the antigen from the outside, breaks it down, and presents it on its surface. Call it exogenous antigen. Cool? That makes sense? I'm going to ask you a trick question. So, by looking at this, can you tell me which, it's actually like 1 or 2 out of 10, but which MHC molecules can be found on the surface of, let's say, dendritic cell? Classes, I mean.
Of what cell?
Dendritic cell. Which MHC molecules can be found on the surface of a dendritic cell?
Both of them.
Say again?
Both classes.
Perfect, yes, both. Because dendritic cells are nucleated. And this is really important. It means that all your antigen-presenting cells, now just keep it in mind, because you'll see the importance of it in a second. All antigen-presenting cells carry both MHC class 1 and MHC class 2. That idea makes sense? Now, what is the role? Like, what is the big idea? In addition to the role of MHC, especially MHC1, to show your immune system if the cell is screwed up or not, if it's infected or not, cancerous or not, these MHC molecules contribute to the tissue compatibility. What happens in transplantation if you don't do anything? Immune system attacks the transplant. Does that make sense? Why? Because immune system is used to this, and your transplant is, let's say, this. For your immune system, this is absolutely foreign. Are we clear? So let's jump in our T cells. So it's called cellular or T cell immunity. Okay, so what do we've got here? Where do they start, T cells? Any idea? Where do they originate? I'm going to give you a hint. Those are the blood cells, white blood cells. Where should they start? Bone marrow, of course. But then instead of staying in bone marrow, so they're born in Cleveland, but for their education they moved to Columbus and attend Ohio State. So they mature in thymus. And during maturation, 2 processes happen. Now look, there is a positive selection. What is that? Your T cells, unlike B cells, listen, they can't just recognize antigen. Antigen has to be presented to them by antigen-presenting cells. Does that make sense? And the presentation happens through either of these 2 MHC classes. So, first imperative for a successful T cell is recognize MHC. So during the positive selection, listen, during the positive selection, cells that can recognize MHC survive. Cells that cannot, they're useless, right? They go in apoptosis. If this mechanism fails, you have a bunch of cells that work and a bunch of cells that simply don't. Okay? Now, negative selection is basically the same as with B cells. It's ignore self-antigens. So again, if you have a self-reactive T cell, are you following me? Self-reactive T cell, it should go in apoptosis. What happens if negative selection fails? What do we call those diseases? When negative selection fails and you have self-reactive T cells. Autoimmune diseases, yeah. Like autoimmune diseases like diabetes, type 1 diabetes. Okay, does that make sense? Same is true for B cells, by the way. We good so far? So let's say they were successfully put through positive and negative selection. Now they totally mature. They seed lymphoid tissues. And just like B cells in the lymphoid tissues, antigen exposure. This is the crucial moment. I just told you, but I'm just checking if you're listening. Can T cells recognize the antigen directly?
Yes? No.
And they can't. This is why I pointed your attention on this, right? So they can't recognize the antigen directly. So you have to have antigen-presenting cells involved. Clear? We're good so far. Turns out we have two gigantic populations of T cells. CD4 T cells they get presented the antigen via MHC Class 2, and CD8 via MHC Class 1. Now remember, Julian absolutely correctly mentioned that antigen-presenting cells have both, right? So your garden variety dendritic cell can activate CD4 because it has MHC Class 2, and CD8 because it has MHC Class 1 as a nucleated cell. Okay, that makes sense? This strict separation, CD4 by MHC2, CD8 by MHC1, is called MHC restriction. As you probably already suspect, it's not always. There are some really rare, but there are some exceptions. They were experimentally demonstrated that sometimes it's not. But for our intents and purposes, again, MHC restriction is CD4 recognizes MHC2, CD8 recognizes MHC1. Does that make sense? And that results in the generation of a variety of what's called effector cells. So for CD4, T helper, yeah, whatever. Two, oh, well, technically three, yeah. Okay, so we've got memory, CD4, that must be self-explanatory, right? Memory cells. You have T helper cells, and you have T regulatory cells. So, the diagrams in the notes, I don't remember from top of my head, they can be more detailed. This is really what I want you to know. T helper, help, we'll figure out how. T regulatory, regulate. Memory cells, is that clear? Now, what do Tregs do? You don't want the immune response to last forever. Tregs dampen the immune response. Are we clear? As a matter of fact, in many autoimmune conditions, you can see that Tregs are either dysfunctional or their numbers are diminished. We clear? Good? We're going to go back to T helper, don't worry about it. What about CD8s? CD8s differentiate into, obviously, memory CD8 and cytotoxic lymphocytes or killer T cells. We good so far? Good? Now, we'll figure out what they do. We have what do T helpers do? T helpers increase macrophage activity because, surprise, surprise, these belong to CD4 class, right? And they can recognize MHC Class 2 on macrophages and stimulate them. They increase B cell activation. It is so-called T cell dependent B cell activation. And they are absolutely instrumental for cytotoxic lymphocyte maturation. Does that make sense? Now let me ask you a simple. So again, T helper cells are like coach, football coach. They don't do shit in terms of, getting rid of a pathogen. Does that make sense? They don't phagocytose, they don't induce apoptosis, nothing. What they do, it's like put what's his name, the Chiefs coach, Harry Reid, I think. Yeah, that really big fat guy who looks like he's gonna have a stroke in a second. So put him on the field, he's gonna die there. But without him, they would never come to the Super Bowl, right? So like commanding quarterbacks and linebackers and I don't know, whatever. So the point is, T helpers help to macrophages to become more mature, more specific. They stimulate activation of B cells and production of antibodies and maturation of cytotoxic lymphocytes. So they obviously are most important immune cells. Well, guess what? CD4 cells, all CD4 cells, are gone in AIDS, in uncontrolled HIV, right? And this is why immune system is completely trashed. It's not just somebody doesn't have B cells or somebody doesn't have CDLs. Those are unpleasant situations, but they're kind of manageable of sorts. Okay. Now, what about does that make sense? The whole idea. Now, what about cytotoxic lymph? And again, you can see the connections here: connection to innate immunity, connection to humoral immunity. What about CDLs? What do they do? Remember, we mentioned NK cells, natural killers, that send cells to apoptosis. So there are two mechanisms how they do it. This is the CTL. This is the infected cell. Now, to save my life, I don't remember which cell has what. One of them has ligand. One of them has receptor. For some reason, I think that infected cell has a ligand. Maybe? Really, it's not important for our purposes. And CTL has a receptor or vice versa. It's called Fas ligand, Fas receptor interaction. It looks like two cells shake each other's hands, doesn't it? Check this out. They kind of shake each other's hands. Make sense? When they do that, infected cell goes to apoptosis. Another option is for CTL to release proteins that are called granzymes, which will be able to penetrate and get into the infected cell via proteins called perforins. Perforins, as you can imagine, perforate, right? We're good so far? So perforins will perforate the infected cell. Granzymes will enter the infected cell, and what do they call? Cause apoptosis. So, kind of a quick summary, what we've got here. We've got specific activation of CD8 cells via MHC Class 1, which results in formation of cytotoxic lymphocytes that will induce apoptosis one way or another of infected or malignant cells. An activation of helper branch and regulatory branch, and helpers will increase activity of macrophages, will increase activation of B cells and antibody production, and will help generate CTLs. One important feature of CTLs that I want to highlight in terms of innate immunity. This is the thing. So let's say I am a cytotoxic lymphocyte. I know, look, this is normal. I know that this is normal. And I know that this is what I'm trained to kill. So I'm going to kind of run around looking for the cells that have this on the surface by MHC Class 1, and I'm going to kill them. That makes sense? What if some cells are infected with a different virus, like this? Am I going to kill them? Nope. I'm not trained for this. You see what I'm saying? This is the specificity of the response. You good? Now, really, I know it sounds terrible, but this pandemic was great for teaching, well, some way, examples. But think about humoral immunity, the B cell immunity that we're talking about, and T cell immunity that we're talking about from the perspective of coronavirus infection. Antibodies can neutralize the virus before it gets into the cells. Does that make sense? So that provides sort of a preventative branch. This is why you want to give antibodies to immunocompromised patients early or even before the infection. What are T cells good for? They're good for wiping out cells that are already infected. Does that make sense? So going back to the variant story, everything that's being tested right now is tested for, can this variant escape antibody response? Okay, neutralization is reduced, I don't know, an order of magnitude. Big deal. Because what it means is that person who's vaccinated, they're going to develop infection. They're not going to develop disease because T cell responses are incredibly robust, just unbelievably robust. And there is no evidence towards, and people study, it's not like nobody studies, people study. And so far, none of the variants can escape T cell responses. That make sense? Good? Okay, we're going to wrap up. We're going to chat about some other stuff on Tuesday.